Okay, so in here you have your bank of resistors, and you got your light resistor, which is what we used in the last couple of lessons. And right beneath it you have what's called a thermal resistor. So the problem is we really didn't specify much about that component, and there's lots of different components. What this does as the temperature changes, as it gets hotter or colder, if I put my fingers on it, it's going to change the resistance between the leads, kind of like turning the knob, and it's going to change the values that come into the Arduino. The problem is that we then need to figure out how to convert those values to something that makes sense, like degrees Celsius or degrees Fahrenheit. But there's really no information on that exact component, and I'm not supplying you with specific code for a reason. What I want you to do is to pull up, I lost my site. Give me just a moment. I just had it here and it disappeared.
Oh, Mr. Alec?
Yes, sir?
I just wanted to say I got the new Nano thing, and when I tried to use it, same error code happened as last time. It's still not working. And it might be a cord, actually. I doubt it. I don't know.
Did I send another USB cable in there?
Yeah, you sent one. It's just way too small. I don't think I can use that.
See if you can just hold it near your computer or your desktop and see if that cord is doing it. Because I can mail you out a longer cord. I can get you like a 9-foot cord if you'd like.
Alright.
But yeah, it's probably the USB port or USB cable if that's acting up. So what I did on this experiment for lesson 2.5, I entitled it Measuring Temperature with a Thermistor, or a Thermal Resistor, and I nicknamed it a Discovery Experiment because I included typical components, I included a description, and there's nothing else. What I want you to do for today's lesson is to Google, or whatever your favorite search engine is, something to the effect of Arduino thermal resistor, and look for some projects that are out there. Most of them will hook to the LCD panel, which is why I included that in your parts list. And most of this other stuff you will need. You may or may not need this resistor, depending on how it's wired and how it's built. We do have a thermistor, but I really didn't tell you anything about it because we don't know any part numbers or any information or any data sheets on that. But let's see if we can find some projects online and build it according to their instructions and upload their code and see if it gives an accurate reading. What I want you to do is to find some code, find a project, try and build it, and see if it works. And then in the discussion board, if you remember, at the very beginning of this whole class, I'm going to go backward one page. At the very top, there was and I think this will show up for you. Let me switch roles so it looks more like your screen. This should, now it's not showing up for me, but it should show up for you because you're listed in a group, but there's a general discussion board. It's not letting me in because I'm a quasi-student right now. I just switched my status. Under the general discussion board, what I'd like you to do is post your findings, your code, and your experience with trying to build someone else's code. If it doesn't work, let's see if you can find a different example. But basically, try and pull up Google, Bing, whatever you want to do, Arduino thermal resistor code. And you may want to follow it by the word tutorial. Try and build one or two projects and see if you can get an accurate temperature reading from your thermal resistor. I'm going based upon the fact that most common room temperature is probably about 70 to 72 degrees. So if you wire this up and you get your reading coming in at about 70, 72 degrees, somewhere in there, it's probably pretty accurate. One thing you might want to do at that point is when you get a reading inside is maybe you can go outside. If you can hook it up to your battery power, go outside, and let it adjust to the temperature, turn it on, and see what the temperature reading is outside. Do you agree with that setting? Depends on where you are. It, maybe anywhere from 20 degrees if you're in Minnesota up to 80 degrees if you're in Hawaii. But see if it's giving you an accurate reading on your thermistor, and see if you can edit some of the values. There's a lot of little witchcraft that goes into this sensor. It's typically not a direct correlation between the reading and the degrees, and there's some weird code in there that you may have to tinker with and experiment with the numbers. And what I want you to do is post your results on the forum. What did you find that worked? What code did you find worked? And do you think it was accurate? And what we're going to do in the next lesson is come up with some approved code that seems to work and display accurate results. But I want you to experiment a little bit with some of the tutorials. Find what's out there. You're most likely going to have to hook up your LCD display, so the wiring may not be what you currently have, but look through the code, wire it up, and see what it's giving you, and does this seem to be an accurate result? And then post that in the discussion forum at the very top of this page for this class. And that's what I'll leave you with for today. I'm not going to give you a whole lot of instruction. After this, we're going to start getting into some more advanced components and some different operations, and we'll be branching into some other projects where we're pulling several components together. We're probably going to add in a scorekeeper to your Simon game, and we may change a few other things around and start learning how some other things operate on the Arduino kits. So for today, a little bit of internet research. Try and find an example project, although you're probably going to see lots of disclaimers that your thermal resistor might be different. It might not. We don't know, because we really don't know anything about that little black component down there, that little chip. But we're going to try and troubleshoot it, see if we can find something that works that will give me a fairly accurate temperature reading. So with that, I'll let you start exploring and tinkering.